Hello everyone, welcome to MemoNeet. I am Aprachita, your chemistry SME. How are you all doing? I hope everyone's preparation is going good and all of you have appeared for BPT 5. Yes, so how did it go? How many marks you scored? You can tell me in the comment section of this video that how much marks you have scored in chemistry and whether our lectures were helpful for you. You were able to solve the questions or not. So you can let me know through the comment section of YouTube. Alright, so please comment whatever you are feeling, if you are liking the lectures or not. Okay, see, we are doing a lot of efforts to make you understand the thing. So if you are liking it, whether you are not liking it also, so you can let me know in the comment section. Okay, so let me know if you prepared well for the BPT 5 and our lectures helped you in achieving good marks, right? So now today I am going to talk about the next test, that is the BPT 6. So if I show you students the BPT 6, it is going to be held on 14th of July, as you can see, and it's a cumulative test. So you have also appeared for one cumulative test earlier, that is BPT 3. So students, in case any one of you have not appeared for the previous test or you have purchased the test series later, so don't worry, we have got you covered. So what you will be doing in this particular test is that on 14th of July you will be having your cumulative test. So cumulative test means this test will cover all the chapters from your previous test. Okay, so that in case anyone has missed out on any chapter, you have not studied it well, or you were not able to give the test for any reason, so you can now study that chapter and now prepare for that. Okay, so that's why we have given you a 13 days time, also means 2 week time is there for you to prepare for your test. So again, the chapters will be all those which you have studied earlier, that is electrochemistry, if I'm talking of chemistry portion, structure of atom, chemical bonding and molecular structure, solutions, and some basic concepts of chemistry. Okay, so these all chapters are going to come in your BPT 6 and we are going to prepare for that as well. Okay, so let me tell you the plan what I have got. So I'll be revising all the chapters, okay, one by one, that are going to come in the exam. In case you want to study the chapters in detail, we have given you all the video lectures on YouTube. Those who have not watched it yet, please go and watch the video lectures of the chapter that you have missed. Okay, and then come back to these videos to revise. So we are going to actually revise the chapters and the revision will be done using the questions. Okay, because ultimately you people have to solve the questions there and you need to know what is the approach of solving the questions, how you are going to solve a particular kind of question, and how are you going to perform in the NEET exam, right? So you need to know the strategy as well, the approach as well, and the kind of questions, yes, that are also very important, the kind of questions that we are going to get in the exam. Okay, so first of all, to revise these chapters you can go through the video lectures. All right, then on our MemoNeet app, okay, those who have got the Allied Plan subscription, on the MemoNeet app you can go through the points to ponder. Okay, so in Brahmastra revision Patrika there is a section for chemistry which is points to ponder. Okay, now in that points to ponder we have given you all the type of formulas that are required to solve a particular chapter. Means a chapter ke whatever the important formulas are there, you can find all of them in one place, means the important points and the formulas as well. So go through that. Okay, and there is a portion called line by line NCRT. Okay, now what does that mean? So you know that how NCRT is, how much important it is for your NEET preparation, because questions are directly or indirectly asked from NCRT only. Okay, so in our app we have this feature where we have given you questions from every page of NCRT book. Means if you want to go to a particular chapter, you can attempt hundreds of questions that will be related to the NCRT. Okay, in that way you will be able to revise the NCRT also and you will be able to solve the questions also. So apart from watching these lectures, I want you to do these things on the MemoNeet app. Go through the points to ponder, go through the line by line NCRT and solve the questions there. In case you are not able to solve any question there, you can ask me. Now how you can ask me? You can either comment on the YouTube section, or you have this Telegram group. So you can actually go and ask the questions there. All right. And those who have enrolled for the BTS Brahmastra test series, you have got a BTS support group also. There you can ask your doubts, that will be immediately resolved. Okay, so see, we have given you so many things, so many features are there. It's just that you have to use all these resources and work hard to achieve your goal, right? Okay, so I was telling you about this chapter. So I am starting with electrochemistry. Why? Because this is the chapter that we have recently did. Okay, so it is still afresh in our mind. So what we will be doing is, today I'll be talking about the numerical problems, or the questions that you people will be getting in your electrochemistry portion. This is an important chapter which carries a good weightage as well. Okay, so how to solve the numericals, how to approach to a particular question, that we will be discussing today by discussing various type of questions. Okay, so stay till the end, all right, and try to solve the question side by side. Keep your notebook and pen ready and try to solve the question along with me. Okay, everyone. Okay, everyone, so let us start with our first question, which is two half cell reactions are given below. So here we have cobalt 3 plus iron plus electron gives cobalt 2 plus. The E naught for this cell is given minus 1.81 volts. Then 2 aluminium ions plus 6 electron give aluminium. Again, the reduction potential is given plus 1.66 volt. The standard EMF of a cell with feasible redox reaction will be, so this is actually your PYQ, okay, that I have taken from our NTA PYQ book. See, here you will be getting the year name, the type of question, and the NCRT tagging as well. So see, these kind of questions will be asked in the exam which are related to your EMF of the cell. So I have told you when we were discussing this thing, what is EMF? EMF means the electromotive force of the cell, and we can call it as the cell potential also. Okay, E naught cell, if we are talking about the standard electrode potential or standard cell potential, all right, otherwise just cell potential will be E cell. Okay, so we have to find out the EMF of this particular cell. Now how you are going to find out? So EMF of the cell is actually the difference between the reduction potentials of the electrodes, that is of the cathode and the anode. Now from this particular question, how will you get to know ki which one is the cathode and which one is the anode? Okay, so you know that in a particular galvanic cell, see, I'm revising the concept also for you people. So in a galvanic cell, which is your electrochemical cell, we know that the cathode is the one which is attached to negative terminal of the battery, means which is negatively charged, all right, and reduction takes place at the cathode. Okay, whereas the anode is the one which is positively charged and their oxidation takes place. All right, so you know these are the reduction potentials. So more the reduction potential, if the reduction potential is more, means that particular species have more tendency to get reduced, means they will be preferring reduction and that reaction will be happening at the cathode. So always take that reaction which is having more electrode potential as the cathode reaction, and which is having a negative potential or less potential value, less electrode potential, you have to take it as the anode. All right, so the E cell or the EMF of the cell or E naught will be given by E naught of cathode minus E naught of anode. This is the formula. Okay, E right minus E left, and by convention always cathode is taken at the right and anode is taken at the left. Now from here I have told you that this one will be the reaction happening at cathode and this one will be at anode. So here I can write E naught of aluminium minus E naught for the cobalt. Okay, now just put the values here. All right, when you will put the values, plus 1.66 minus, then minus 1.81. okay, so it will become 1.66 plus 1.81, so 7, 4 and 3, so it will become 3.47. and see, there are two options given to confuse you, plus 3.47 and minus 3.47. so the answer will be correct if you know the correct formula and you know which one is the reaction happening at the cathode and which one is the reaction happening at the anode. So answer for this question would be option number D. Okay, plus 3.47 volts. All right, so when, see, in the question they will not give you for cathode anode, they might give you, but you have to see from the values. The higher the reduction potential means more tendency to get reduced, and the reaction will be happening at the cathode, keep that in mind, and the other one will be happening at the anode. And usually for anode the value of E naught will be negative, okay, it's usually happening. Okay, so the answer is plus 3.47 volts. All right. Now students, this is the next question that I am going to discuss. It says find the EMF of the cell of in which of the following reaction takes place at 298 Kelvin. Nickel plus 2 Ag plus gives nickel 2 plus 2 Ag. E naught cell is given 2.303 RT upon F is given. So we need to find the EMF of the cell, means the electromotive force. So how to solve this question? So you need to know that which question requires which concept, right? In the previous question we applied the concept for the cell potential, which is E cathode minus E anode. Okay, now in this particular question you will be applying the Nernst equation. Okay, so you will be applying the Nernst equation, which is required to calculate the cell potential. So the cell potential E cell is given by E naught cell minus 2.303 RT upon NF log of the concentration of product divided by the concentration of reactant. Okay, where E cell is the cell potential, E naught is the standard cell potential, standard electrode potential, RT, you know, gas constant temperature, N is the number of electrons that are involved in the reaction, F is the Faraday's constant, and these are the concentrations. So particular reaction here it is given, students, nickel plus 2 Ag positive is giving you Ni2 positive plus 2 Ag. Now clearly you can see here that if nickel has to convert to Ni2 positive, it has to lose 2 electrons, okay, and again 2 Ag plus need to gain 2 electrons to convert to 2 Ag. So what I have to find from here is the value of N. So the value of N is going to be 2 in this particular reaction. 2 electrons transfer is being happening, right? So in this case, students, 2.303 RT upon F value is already given 0.059. So putting the values, E cell will be equal to, now E naught cell is also given 1.05 minus, so it will be 0.059 divided by N. We are just left with N now, because itni value to हमें given थी यहाँ पर. See this one. This value was already given. So N's value is 2 actually, and log of, now what is the product in this case? Nickel 2 positive, because ये जो solid होता है ना यहाँ पर, इसकी concentration unity होती है, so we are not considering that. तो nickel 2 positive divided by silver ions concentration, but जो stoichiometric coefficient है, it will go in the power, means square. Okay, इनकी concentration is already given in the bracket, which is 0.001 molar. So you just need to put the values now and do the calculation. So 1.05 minus 0.059 upon 2 log of 0.001 and 0.001 whole square. Okay, so that will, you have to solve it out. See, I tell you how to solve this if you are not able to do. See, 1.05 minus 0.059 upon 2. See, log you need to know how to solve. So it's say यहाँ से 1 will cancel, so it will be 0.001. Okay, so from here you can write it out. So it will come out to be like this. So students, यहाँ पर you will be writing log 1 upon 10 to the power minus 3 now. So it will come out to be 1.05 minus 0.059 upon 2 log 10 to the power 3. So you know that log 10 to the power 3 would be 3 log 10, and log 10 की value is 1. So यहाँ पर 3 आ जाएगा, right? So it will be 1.05 minus 0.059 upon 2 into 3. So when you will solve it, it will come out to be 0.9615 volt. Okay, 0.9615 volt. Just solve it. See, I told you how to solve the log as well. Okay, so this is how, using the Nernst equation, you can find out the value of E cell. The E naught cell will be given, the reaction concentrations would be given. Alright, you just have to put the values and perform the calculations. Okay, this is how we are going to solve this particular question. So now let us solve the next question for a cell involving one electron. Okay, so the electron number is given 1. E naught cell is given, which is 0.59 volts at 298 Kelvin. The equilibrium constant for the reaction is, so we need to find out the equilibrium constant, means Kc for the reaction. Now which relation are you going to apply for finding out the equilibrium constant, that you need to see. So again we will be applying the relation which says E naught cell is equal to 2.303 RT upon NF log Kc. Now you will be thinking ki how we have got this particular expression. Just put the values here, you will get the value of Kc. But you know, according to the Nernst equation, E cell is equal to E naught cell minus 2.303 RT upon NF log of concentration of product and upon concentration of reactant, जिसको हम log of QC भी लिख सकते हैं. Okay, now you know that at equilibrium, okay, what will be happening at the equilibrium? The cell potential will be 0, means E cell would be 0, and this QC will be equal to the equilibrium constant. So from here we have got this relation. Okay, in case you were having any doubt, I have told you how we have got this particular relation. Okay, now just put the values. N is already given and 2.303 RT upon F value is already given. So E naught cell is 0.59. So from here 0.59 will be equal to, it will be 0.059 upon 1 log Kc. Very simple question, okay, but see, it has been asked in Neet, so they have made your calculations very easy, students. All right, so here it will go in the denominator. All right, okay, so what it would become? Yeah, so it will be 1000. I am showing you the calculation so that you have no confusion. So it will cancel out. It will be giving you 10. So log Kc will be equal to 10. So the value of Kc would be anti-log of 10. Okay. So anti-log of 10 would be equal to 1 into 10 to the power 10. Alright. So that will be the anti-log. And yes, the answer is going to be option C. See, using the Nernst equation, we have these two relations between the equilibrium constant, and one more relation is with the Gibbs free energy. Okay, so we will be solving this question I have solved. See, I have solved the question for the cell potential, then we did a question for Nernst equation, how to solve that. Then we have done a question related to the equilibrium constant. We are doing all the PYQs. Okay, then after that, there is a question that is related to the Gibbs free energy change. Okay, so I hope you remember the relation of the Gibbs free energy with the cell potential. We'll be solving a question based on that. So students, this is the question that has been asked in NEET 2022 examination. You see that all the topics are very important. You can get the numerical based on any topic, okay? So the question is, standard electrode potential for the cell with cell reaction is 1.1 volt. Standard electrode potential means E naught cell is given to us, okay? The reaction is given, zinc plus copper ions gives zinc ions and copper. Now if I write the cell different reactions, okay, so in this case zinc is giving you 2 electrons and copper plus 2 electrons gives copper. So it means the number of electrons involved in the reaction are 2. Now I have to calculate the standard Gibbs free energy change. The value of F, that is the Faraday's constant, is given. See, if it is given 96487, you have to take 96487 only. Otherwise you can take the value as rounded off value, which is 96500 as well. Okay, if not given. If it is given, you need to use that value only. Now what is standard Gibbs free energy change? So it's actually a thermodynamic quantity, okay, that we calculate for the reaction in this particular case. It is dependent on the cell potential. Okay, how it is dependent? The relationship is NF E naught cell. Because we are talking about the standard values now, so that's why we have put the naught. Okay, so that is the thing in this particular case. All right, so see, all the values are given, you just have to put the values. Okay, see, the questions are not difficult that have been asked in NEET. Okay, direct questions are asked. It's just that if you know the formula, so that's why I'm telling you that revise the formulas also. So the delta G naught will be minus N. So N is 2 into F is 96487. Okay, students, and E naught cell is given 1.1. Okay, so when you solve this, it will come out to be minus 212271.4. It will be joule per mole. Okay, now you can convert it to kilojoule by dividing it by 1000. So decimal will shift to 3 places. So it will be minus 212.27 kilojoule per mole. So that will be the value for delta G naught. So from here you can see minus 212.27, two values are given to confuse you, but the one will be correct one would be kilojoule per mole. Okay, so the answer is option C. Alright, so that was the question that was related to our Gibbs free energy change. Now let us see the next one. So students, the next question is the conductivity of a centimolar solution of KCl at 25 degrees Celsius is 0.0201 0.0210 per ohm per centimeter, and the resistance of the cell at 25 degrees Celsius is 60 ohm. The value of cell constant is. Now this question is related to cell constant. So I have a direct formula by which you can solve this question, okay, but I need to tell you how to approach this question, like we will be revising it also na. So students, you know the formula of resistance, okay. So resistance R is given by rho L upon A, where rho is the resistivity or the specific resistance of any conductor, right? So it's the resistivity, and now you know that 1 upon rho is given by kappa. The like reciprocal of resistivity is what? Conductivity. Okay, so conductivity is given, means kappa value is given to us. So from this particular relation, if I find the value of 1 upon rho, so 1 upon rho would be equal to R L upon A. Okay, so it will be 1 upon R, so this R will go in the denominator, alright. So 1 upon R into L upon A. So L means the distance between the electrodes. If I'm talking about the electrolyte, distance between the electrode, and A is the area of cross section of electrodes. So from here I can put 1 upon rho as kappa. So now 1 upon resistant. So students, 1 upon resistance means reverse of resistant is known as the conductance. Okay. So I can put it as G also. So kappa is equal to G, and L upon A. Now this L upon A term means the ratio of the distance between the electrodes to the area of cross section of the electrode is known as cell constant, and cell constant is used to determine the conductivity also, right? If we know the resistance. So it is denoted by G star. So G star. So you must know this relationship, that is conductivity is equal to, I can write it here for you, conductivity is equal to conductance, okay, into cell constant. Now we don't require conductance here as resistance is given, okay, resistance is given and conductivity is given. So I will put the value like this only using this formula. So kappa is equal to 1 upon resistance into cell constant. I can directly write G star. So the kappa value is given 0.02010, okay, is equal to 1 upon resistance, which is 60 ohm, alright, into cell constant. So from here you can find the value of cell constant as 0.0210 multiplied by 60. Okay, centimolar was given na, don't get confused, that was the concentration given. Centimolar solution means 1 upon 100 molar, means the concentration is 0.01 molar. Okay, so when you solve it, the value of the cell constant will come out to be 1.26. okay, per centimeter. So the answer is option B. Now how the unit is per centimeter, because it's L upon A na, length ki unit is centimeter and area is centimeter square, so it will come out to be 1 upon centimeter. That will be the unit of cell constant. Okay, so they can give you any value, they can give you conductance also, they can ask you conductivity, cell constant, anything. So you must remember this relation, all right, and this one as well. So that's why I'm telling you the derivation, the concept side by side, so that you can understand the concept behind the question and see how to approach a particular question. Okay, students, next question. The molar conductivity of 0.007 molar acetic acid is 20 Simon centimeter per mole, Simon centimeter square per mole. Molar conductivity is denoted by lambda m. So I am writing this, whatever is given first. Okay, I need to find out the dissociation constant of acetic acid. Okay, concentration is also given 0.007 molar. All right. Now the limiting molar conductivities are given. So what is the concept you will be applying here? Let me tell you first. So whenever we have to find out the dissociation constant, firstly we need to find out the degree of dissociation. Okay. Now what is degree of dissociation for this type of electrolyte? So here we have a degree of dissociation alpha. It is given by lambda m, means the molar conductivity, divided by the limiting molar conductivity. Okay. Limiting molar conductivity is the conductivity when the concentration of the electrolyte approaches to 0. Then when you find out the degree of dissociation, you can find out the dissociation constant, which is C alpha square upon 1 minus alpha. Now for weak acid, okay, now this acetic acid is a weak acid. Now for weak acid, the value of alpha is very much less than 1. So the value of dissociation constant is C alpha square. So it means to find out the value of dissociation constant, first I need to find out alpha. Okay. Now lambda m is given, means the molar conductivity is given, but limiting molar conductivity is not given. Limiting molar conductivity of respective ions is given. So you know by the Collar's law, right? So by the Collar's law, limiting molar conductivity of any electrolyte is the sum of the limiting molar conductivities of respective ions. So means acetate ion plus the limiting molar conductivity of hydrogen ions. So I will add them up. It will be 50 plus 350. So it is coming out to be 400 Simon centimeter square per mole. Right, now you have got the limiting molar conductivity as well. So let's calculate the value of alpha, which is molar conductivity upon limiting molar conductivity, 20 upon 400. So it's 1 by 20. All right. तो 1 by 20 आ गया यहाँ पर. Now just put the values. Ka will be C alpha square. So C is 0.007. No, 0.007 को we can write as 7 into 10 to the power minus 3. All right. Into alpha square means 1 upon 20 square. So you just need to solve this now, and when you are going to solve it, it will come out to be 1.75 into 10 to the power minus 5. Okay, this is the value that you are getting, 10 to the power minus 5 mole per liter. So that's your dissociation constant. Okay, so whenever you are asked to find out the dissociation constant, first find out the degree of dissociation and then solve this particular question. Okay, try to recall this concept as well. Alright, so now we'll be moving ahead with one more question that is also related to Collar's law, and that's actually a very interesting question, students. Let me show you. So students, the question is, following limiting molar conductivities are given. Limiting molar conductivity for H2SO4, K2SO4 and CH3COOK are given, X, Y, Z respectively. I have to find out the limiting molar conductivity of the acetic acid, okay, CH3COOH. So how you will find out? Again, you will be applying the Collar's law, okay. So according to that, the limiting molar conductivity of the acetic acid would be equal to the limiting molar conductivity of acetate ion plus the limiting molar conductivity of hydrogen ion, okay, respective cation and anion. But we are not given the direct values, we are given the values for some compounds like H2SO4, K2SO4 and CH3COOK. Now from that I have to derive this expression. So here it's given XYZ. In some questions you will see the PYQs. Now you will see कि in some questions values are also given. तो वहाँ पे instead of XYZ value put करके we can find the value. So this is a very interesting question, I feel. So from here, now you basically want the acetate ion and hydrogen ion. So acetate ion हमें कहाँ से मिलेगा? We will be getting the acetate ion from the CH3COOK. Okay. So from here, right, we will be having the this one. Okay. but I need to subtract K also, that I will do later. Now I want hydrogen ion, so I'll be adding the limiting molar conductivity of H2SO4. But in H2SO4 there are two hydrogen ions, okay? So I need to divide it by 2 because I just want one hydrogen ion for me. Alright. Now what I have to subtract? I have to subtract this K from here, potassium, and I have to subtract sulfate from here. So I have potassium sulfate here. Alright. So from in this case, I will be subtracting the limiting molar conductivity of potassium sulfate. Of course, I want one potassium ion and sulfate ion divided by 2. So of course, I'll be dividing it with 2. So now you see, I'm just left with this much. That is the acetate ion and one hydrogen ion. Rest I have subtracted. I hope you are getting it right. So this is how such type of questions have to be done. Now put the respective values asked. So for this, it's Z, then plus. For H2SO4, it's X upon 2. And for K2SO4 is Y upon 2. So I can write it like this also, Z plus X minus Y upon 2. And or I can write it as X minus Y upon 2 plus Z. So clearly I can see this is the first answer. See, I'm again telling you that instead of XYZ, they can give you any values also, okay, some values. So just simply, you have to see ki which ions you require. So I required acetate and hydrogen na. So first of all, I wrote acetate and hydrogen. Then at the end, subtract. Okay. So don't subtract simultaneously. I would suggest ki at the end, subtract it. So it becomes easy for you. Okay. Alright, so now next question, students. So there were some Faraday's law also for electrolysis. So I have one question related to that as well. So students, the question is, number of Faradays required to produce 20 gram calcium from molten calcium chloride is, so I have to tell the number of Faradays. So you know, students, that according to Faraday's law of electrolysis, so whatever is the amount of any substance which is deposited or liberated at the electrodes, okay, even if it's deposited or it's liberated, it is directly proportional to the amount of electricity passed. Okay, this is the first law of Faraday's law. First Faraday's law means it will be directly proportional to the amount of current passed. And you know that what is Faraday? So basically 1 mole of electrons, okay, 1 mole of electrons carry 1 Faraday of charge. This you need to remember. 1 mole of electron carry 1 Faraday of charge. Okay, you know that the value of 1 Faraday exactly, it's 96487, right? Coulomb per mole, of course. So you can take it as 96500 for easy calculations, but the exact value is this. So this is what 1 Faraday. 1 Faraday is how many how much charge is carried by 1 mole of electrons, because you know that ki 1 electron per kitna charge hota hai, 1.6 into 10 to the power minus 19 coulomb. And when I multiply it with the 1 mole, means if I multiply it with Avogadro's number, then I will get this value. Okay. So that's 1 Faraday. Now you know in this particular reaction, now let's come to the question now. That was the concept used. So calcium chloride, it will give you calcium ions and 2 chloride ions, of course. Okay. So calcium ions you are getting. Now if I want to have calcium from it, okay, so calcium ions need to have 2 electrons, 2 moles, and they will give you calcium. Okay, means 1 calcium ion will require 2 electron to convert to calcium and get deposited. So it means if you have 1 mole of calcium, it is requiring 2 mole of electrons. Okay, 2 moles means, by that I means that if you have to reduce 1 mole of calcium ions, you need to have 2 mole of electrons. Okay, so 2 mole of electrons will carry how much charge? 2 Faraday of charge. Now 1 mole calcium, how much it weighs? You know the molar mass of calcium is 40 gram per mole. Okay, so it means if I have to if I need 40 grams of calcium, 2 Faraday of current or electricity is required. I hope you have understood it. Okay, from the equation, 1 mole calcium requires 2 mole of electrons, means 2 Faraday of charge. So 1 mole calcium means 40 grams calcium required 2 Faraday. Now in the question, how much calcium is required? 20 grams. So I can do the calculation for 20 grams easily, right? So 20 grams of calcium. So you can do it for 1 gram. Let me make it more easy for you. Unitary method. तो 1 ग्राम कैल्शियम को कितना करंट चाहिए होगा? 2 Faraday upon 40. Okay. So 20 grams of calcium will be requiring 2 upon 40 into 20 Faraday of current. So obviously it will come out to be 1 Faraday. So it means if I have to get 20 grams of calcium from this particular reaction by electrolysis, we need to put 1 Faraday of current. Okay, so the number of Faradays required is 1. If they would have asked you about charge, so you would have written 96500 coulomb per mole. Okay, so that was the question related to the Faraday's law. So this is how you have to solve. So students, I have tried to cover all the PYQs. I have completed the PYQs of electrochemistry. I have taken one question each from every important topic. Okay, numerical basically. So you see a lot of numericals are being asked. All the theoretical questions are asked. I hope you can do that. So still, if you are having any doubts in any of the question that we have discussed today or any other question of electrochemistry, so see, you have 2 days. I have so we have 5 chapters now and we have 14 days. So you can at least give 2 days to each chapter to revise. That's our target. Okay, so give these 2 days to electrochemistry, revise it, solve the PYQs, and what I have told you, solve the questions on the MemoNeet app. Okay, go through the formulas there. And then if you have any more doubts, you can contact us. You can tell me in the comment box if anything else you want me to make a lecture on. Okay, ki ma'am, this topic we have not understood, so can, like, out of the 5 chapters only, so can you explain us this topic again? So I would try to make a lecture on that. Okay, so if there is any such issue, please do let me know in the comment box. Okay, and please do comment here. Okay, I'm not getting any of your comments, so please let me know if you are liking the lectures or not. Okay, and do like and share this video with your friends also. Okay, they will also get benefited from that because I have discussed the most important PYQs of this chapter. All right. So thank you so much, students. We will be meeting in the next session. So until then, revise this chapter, okay, to full and prepare well for your test. Thank you so much.